So hi guys, welcome to YourPedia education. So in this video today I'm going to discuss some previous year questions related to one of the section of your syllabus, that is analog and digital communication. See, my motive in this video or purpose is not only to give you the solution of the previous year question. I have taken few questions. I will discuss on the basis of data whatever I have, what you need to prepare for the next coming exam, what you can expect on the basis of those questions. What are the important relations, equations or formulas you need to remember related to those topics from where these questions are framed. So I want to make this video not only as a solution to previous year question, but at the same time as a learning video for you people, because I believe this analog and digital communication syllabus is bit difficult for those people who have done their engineering in the computer science engineering, right? If you're from the electronics and communication, then this is obviously kind of free for you, because you know in your BTech you have studied this subject really well, and even in GATE exam this is a very major subject for the electronics people. And second thing guys, what I have observed, even most of the questions which are asked under this section, they are the previous year question of the GATE. So when I will be teaching you this subject in the class, so I will discuss and I will try to cover this subject in very compact form. I can understand that the person who is coming from the CSC background, it will be very difficult for him to make the lot of derivations. So I will try to give you people some crux, concluding points, some important relations, and some of the frequently asked questions also in miscellaneous form, right? So according to me, if you remember that data, it will be definitely helpful for you these kind of exam like NIC. So let's start with the first question. The first question is related to basically modulation system. See, whenever we talk about the communication, the modulation is very important topic or basic requirement of the communication. So in analog communication, we talk mostly in broader domain, amplitude modulation, frequency modulation and phase modulation, right? So this question is framed from the amplitude modulation. Now see, we have two kind of the domain, one is time domain, one is the frequency domain. So whenever we are studying the amplitude modulation, frequency modulation, phase modulation, we should prepare in such a way we cover all the parameter of the both domain. So this question is totally based on the time domain analysis. One question more I have taken, that is on the basis of the frequency domain analysis. See, whatever kind of signal you have, obviously it has some spectral component, it contains some frequency. So for that you need to go into frequency domain, you need to know how to plot its spectrum and what are the different frequency components present in the spectrum. So that I will discuss again, right? So right now this question is, consider sinusoidal modulation in an AM system. AM means amplitude modulation system. Assuming no over modulation, the modulation index variable is represented at mu when the maximum and minimum value of the envelope is 3 volt, 1 volt. So 3 volt is the maximum value and 1 volt is the minimum value of the envelope, right? So second thing is that guys, at least you must be knowing the modulation index formula for AM, PM and FM. And formula can be different. It can be different when you are basically provided the data related to its waveform. When you are provided data related to its frequency domain, the formula will be different, right? So as of now I will try to discuss on the basis of whatever data is provided to me. The second thing, if you are going for the exam like NIC, then you must be knowing what are the standard equation which reflect and which shows AM modulation, which shows PM modulation, which shows the frequency modulation. So these all kind of stuff you need to prepare in the periphery of the modulation. And the last and important thing, what are the different method and ways of generation of AM modulation, what are the different ways and generation of FM and PM. At the same time, generation is not important in the communication, detection and demodulation is very important also. What are the different detection demodulation technique for AM, PM, FM. So this periphery complete most of the frequently asked question in exam like NIC, right? So that is my motive for this video. Now let's proceed with this question. Basically it's given, consider a sinusoidal modulation. Is it clear? In an AM system, assuming no over modulation. See, when we talk about the AM, we have the case critical modulation, under modulation, over modulation. Over modulation means its refractive index is not greater than 1. So when the maximum and minimum value of the envelope is 3 volt and 1 volt, find the modulation index. See, we are talking about the amplitude modulation. It means whatever modulated signal we have, the amplitude is modulated, the amplitude is changed. So there are some variation in the amplitude. So if I see and try to conclude the envelope of those amplitude variation for sinusoidal case, I will be getting the envelope in the sinusoidal form. So this is not the standard envelope. This I am saying for the sinusoidal modulation. If your message signal is square wave, the answer will be different. If your message signal is ramp, the answer will be totally different. It depends upon the what kind of the message signal you are using. Since right now we are considering the sinusoidal modulation, so if I see the envelope of the amplitude variation which will be resulted in the modulated signal, they will be kind of the sinusoidal. And it's given in the data, the maximum value is 3, minimum value is 1. So there is a direct formula for modulation index of the AM system on the basis of the data provided for the envelope of the system, Amax minus Amin divided by Amax plus Amin. Just substitute the value, you will be getting the answer 0.5. It means your answer will be guys 0.5. So see, this question can be framed in some other way also, right? But since the data is provided in the form of the envelope, that's why I use this formula. Okay, there is some other formula of modulation index also, but they will be useful for the some other kind of data that I will be discussing later on. Now sir, how to derive this formula? See, as of now, I don't think you should derive this formula, but in case if you are taking classes with me, then definitely I will provide you a supportive PDF document. There you can find the derivation. But as of now, according to me, for the exam like NIC, the derivation is not that much important, right? Is it clear? So this was the first question. Now guys, if I talk about the second question, I told you right now, the spectrum is very important term of any signal, be it modulating signal, be it carrier signal, be it modulated signal. So you can see this question, 1 megahertz sinusoidal carrier is amplitude modulated by a symmetrical square wave of period 100 microsecond. Which of the following frequency will not be present in the modulated signal? They have given you 4 options. What the problem is that there is 1 megahertz sinusoidal carrier, sine carrier is there whose frequency is 1 megahertz. That is amplitude modulated by a symmetrical square wave of period 100 microsecond. Which of the following frequency will not be present in the modulated signal? So from the question, can I conclude we have the 3 kind of the signal given in the question. If I say the first one is the message signal or modulating signal. The first one is the message signal, right? Given in the data. And that message signal is basically, I guess, symmetrical square wave. Is it clear? That is symmetrical square wave, and whose period is symmetrical square wave with period of, I guess, 100 microsecond. Is it clear? And the second is we have carrier signal. Second is carrier signal. And carrier signal frequency is given, FC, I am denoting it, it is given as 1 megahertz. So I can write this as a 1000 kilohertz for easiness. Now see, whenever I talk about modulation, these 2 are only the requirement. One, I need to have the carrier signal. One, I need to have the modulating signal or message signal. If I will give these 2 to the modulator, so he will give me the resultant signal, that will be your modulated. That will be your modulated signal. The result will be modulated signal if you are giving these 2 inputs to the modulator. If it's an amplitude modulator, then the result will be amplitude modulated signal. So the question is, whatever resultant signal we are obtaining here in the frequency spectrum, which of these frequencies is not present? So for that, first I must be knowing what are the different frequencies present in the modulated signal. See, whenever we talk about the amplitude modulated signal, there are 3 frequencies present in the spectrum. One is the carrier frequency, one is the FC plus minus FM, right? So what I am doing, this FC is the carrier frequency again, right? And this FM is the message signal frequency. So you can categorize it into 2 parts further, FC plus FM, and you can write this as a FC minus FM. Is it clear? So again, I am not going to do detailed derivation, that I will discuss, or I will discuss in the classes how to do it. So this one is called as the upper sideband, and this one we call the lower sideband frequency. Is it clear? But this is susceptible, or this is accepted only if we have the single frequency in the message, right? Since the message signal here is symmetrical square wave. So guys, whose period is 100 microseconds. So first we calculate the fundamental frequency. So FM of the message signal will be 1 upon time period. So it will be 1 upon 100 micro. So this will give me, I guess, 10 kilohertz if I am not wrong, right? Now most of the time student commit mistake, they start using only this frequency. See, this is the fundamental frequency, but our message signal is not a sinusoidal signal, it is a symmetrical square wave. And listen guys, I'm not going again into the Fourier series analysis and detailed tools. I'm making one conclusion here: whenever you have some periodic non-sinusoidal wave, then it contains many harmonics frequency along with the fundamental frequency. Now there is second topic which is included into this question. It is a symmetrical square wave, so it contains only odd harmonics. It contains only odd harmonics. So what I'm writing here guys, so in case of the symmetrical square wave, I will say what are the different frequency present. FM will be there, 3 FM will be there, and 5 FM will be there, or so on. It will go on like this, or you can write this up to n FM, where n is equal to 1, 3, 5, 7, 9, so on. Now sir, why this symmetrical square wave is containing only odd harmonics? For that we have various tools for analysis like Fourier series, or we can directly check by applying some symmetry property like half wave symmetry and all. So I'm not going to discuss that all, how to check, it will take a lot of time. So those all things I will discuss when I'm taking the classes for the students who are enrolled with us. There I will discuss in detail these all kind of the things. So as of now it's clear to me that in my message signal there is not only single frequency, there are multiple frequency. So now if we have such kind of case, then the spectrum of the modulated signal will contain the frequency FC and FC plus minus FM. Is it clear? And there will be some n, and for my case this n is equal to only odd because odd harmonics are present. Is it clear? So can I assume now the frequencies present in the spectrum will be FC or FC plus FM and FC minus FM and FC plus 3FM and FC minus 3FM and FC plus 5FM and FC minus 5FM, something like this one. So can I say guys, again this is my 1000 kilohertz, again this will be I guess 1010K, again this will be I guess 990K, and again this will be I guess 1030. Please make the calculation alongside. This will be I guess 970K, and this will be I guess 1050K, and this will be I guess 950K. So if we see this was there in the option, so it is present in the spectrum. So let's check the option once again. The options are 990, 1010, 130. So you see 990 is present there. Yes, 990 is present there. 1010 is present there. And can we say that 1050 is present? And what are the other options guys? Other options are 1030, right? So do we have 1030? Yes, this is also present. So this is present, this is present, this is present. The only one number is not present here, that is 1020K. So that is not present in the spectrum. So the answer for this question will be this one. This is the answer. This frequency is not present in the spectrum of the AM modulated signal when we have the carrier of 1 megahertz and we have the message signal in the form of the symmetrical square wave, right? So the same question can be extended. How this question can be extended for the coming exam? So now I'm framing. He will say the EM signal, whatever AM signal we are getting, that is passed through some filters, right? And filter is a basically frequency selective device which will give you frequency at the output according to its bandwidth. So he will be sharing this is the bandwidth of the frequency. Then tell me at the output of the filter what all frequencies will be present. So if he is framing question like this, one stage ahead he can think like this for the next coming exam. Then you know what all frequencies are present here in the AM signal. I have calculated here in entire detail. These all frequencies are present. These all frequencies are present here. So once you know that the bandwidth of the filter, or once you know the bandwidth of the filter is something like this one, okay, let us suppose he make a problem that filter have bandwidth some, let us say 1050K. So what will be frequencies at the output? So if it's a low pass filter, then obviously it will pass the frequency lower than 1050. So you can mention all the option there. So this is the one thing which I'm sharing, how you can extend the question for the next coming exam, right? Otherwise you can simply ignore this. Otherwise, you can simply ignore this. The answer for the question, whatever was discussed, so the answer is this one, guys. So guys, my point here is that it's not only about solving the previous year question. The point is how you can utilize this data to get the information about what topic I need to prepare for the coming exam, right? Now see, instead of the symmetrical square wave, if you write unsymmetrical square wave, triangular wave, sawtooth wave, then it will not always that odd harmonics will be present. So that is the case I am discussing for the symmetrical square wave, right? So for different waveform, the things will be different. There can be even harmonics also, that we need to see what kind of the waveform is provided with us. So for that, I will be discussing how to break down one non-sinusoidal periodic wave into its harmonic frequency component, and how to check in very short time that which harmonics are present, which are absent. So this was the basically knowledge required to solve this exam, and I believe this is the directly a gate question if I am not wrong, right? So guys, then we have the next question. The next question is, a band limited signal is sampled at Nyquist rate. The signal can be recovered by passing sample through. Option is an RC filter, envelope detector, PLL, and ideal low pass filter with the appropriate bandwidth. See, this is also filter option and this is also filter, but here it's not clear whether RC filter is high pass or low pass. So I can't comment on this, okay? So if the option is filter, so don't get in dilemma, sir, this is also RC filter, this is also filter. Here clearly he is mentioning an ideal low pass filter. Here he is simply making a general statement, an RC filter, so we don't know whether he's talking about the high pass filter or low pass filter, right? So don't get in doubt because of the option. And second thing, guys, is if you see these all option, envelope detector is used for some specific purpose. It is used for the AM demodulation. PLL is used for the frequency. So it means whatever option he have framed here, they are used for some particular or some specific function in the communication. So that's what I told you in the beginning. The questions are never out of the basically syllabus. It's the point, the basically your mindset, how you prepare the question, right? Now if we talk about the sampling, see, whenever you have some analog signal, you want to convert it into digital signal, there are some stages like sampling is there, quantizing is there, encoding is there. And for the processing of data, it might be required you have some analog signal, you need to convert into digital signal. But on the later stage, it is required that you need to get back the original signal from the sampled signal. So the same question is there. A band limited signal is sampled at Nyquist rate. The signal can be recovered by passing the sample through. These four are the options, right? So for most of the people who don't know what is filter, filter is basically a frequency selective device. If I talk about the low pass filter, so this is basically the spectrum of the low pass filter. This is ideal low pass filter, right? This is a ideal low pass filter. This is ideal low pass filter. So if somebody is giving me this like this one, and this I'm saying this is FM, and this I'm saying minus FM. Is it clear? Whether you talk about the F domain or omega domain is the same thing. What does this low pass filter will do? Whatever frequency are there from 0 to FM, it will pass them. So this is known as the pass band of the filter. This is known as the pass band of the filter. So this is for those students who don't know anything about filter. Means if filter is connected in the system, it will pass all the frequency which are from 0 to FM, and this is known as the stop band of the filter. This is known as the stop band of the filter. Is it clear? Whatever frequency component is coming after FM, it will not allow that because there it has zero gain. So this is basically brief of the filter or specifically low pass filter. Similarly for the high pass filter, the situation will be a bit different, right? So it's not possible to discuss here everything. Let's start with the question. Okay. Now guys, what I am assuming in solution, I have assumed this is my signal, original signal. This is my original signal. I am assuming which is band limited as given in the question. So I am assuming my original signal is band limited to frequency Wm or omega m. I am calculating it in the omega domain. You can proceed for the calculation in the omega domain or F domain. Both are the frequency domain, right? So this is again the omega domain. Now how to obtain the sample spectrum? So there is a lot of again concept. We need to go through the impulse train and how to draw the spectrum for the sample signal. So I'm not going to take it here. Again when I'm teaching, I will tell you the shortcut method how to draw, right? You can see the sample spectrum, we are getting the copy of this original signal in the frequency domain which are placed like a carbon copy. right? This is the sample spectrum. And why I have drawn like this, whenever we are sampling the signal, if you want to recover back the original signal from the sample signal, your sampling frequency should satisfy this criteria. Is it clear? Okay. If you are not satisfying this criteria, then there are few errors and which will never allow you to recover the original signal. So whatever I am drawing here, I am drawing this under the condition that omega s is equal to twice of omega m in the frequency domain, or fs is equal to twice of fm in the frequency domain, because in the question it's given that is sampled at the Nyquist rate. Nyquist rate means the sampling frequency is equal to twice of the maximum frequency present in the message signal. So according to that, I have drawn this the sample spectrum. So the question is, once I have sampled the signal, how to get my original signal back from the sample spectrum? You can see this was the sample spectrum. So you can look here now. If you want this signal back from this, obviously you need this part. You need this part. Is it clear? So how to get this part? I have told you just now, use some frequency selective device which will select only this part and reject other part. Who can perform this task? Obviously the ideal low pass filter can perform this task. Ideal low pass filter can perform this task. Is it clear? Now see, in this question the word is ideal low pass filter used. Is it clear? Now if here is not an ideal low pass filter, if practical low pass filter is used, then the question can be again bit of the problematic. So there are the concept of transition band of the practical filter which we need to take into consideration. So that's what I'm saying, guys. There are many things which you can get to learn from the all previous year questions. So it's not only to solve, then just to learn the solution from somewhere else. It's all about analyzing how much you are analyzing the question and what all learning you will be getting from there. So what will be option? Option will be this one. So I have tried to discuss some of the question with you guys, and see, my purpose here was not only to discuss the answer with you. I wanted you get to know, if you are preparing for coming exam, what other kind of question we can expect on the basis of these kind of data. So I hope you got some learning from this session. Thank you.